Okay, let's just have a quick look at this. It goes, first one, prove that this expression here is not a prime when n is a positive whole number. So before we start, let's just have a look at this expression, and what I can do is if I factorize the first two terms, so if I go n, open bracket, that'll be n minus 79 plus 1601. Okay, 1601. Could be any number really. That I'm just trying to see what's going on. Now, to prove that it's not always, what I could do now is I could let, if I let n equal this number, which is 1000. N equal 1601. I know that will be 1601. Okay, and this will be 1601 multiplied by 79 plus 1601. Now, it's a little trick you can use. Now, if I do that, and that will give me 1601 minus 79, and that's going to give me 1671 multiplied by 1522 plus 1601. Now the trick here is, now that 1601 and 1601, you got a common factor there. So what you could do is take that common factor out and factorize it, and you'll get 1522 plus the 1. Okay, because I just took that factor out because it's common in both of them. I should use this red to just show that. That was the trick I've used. So that means that's going to be 1601 multiplied by 1523. Now, by doing that, you've shown that this number, okay, this expression has two other factors other than 1 in itself. Okay, to be a prime has only two factors, 1 and itself. Okay, so this is not a prime as it has a factor of 1523 as well as 1601 and 1. Okay, so let's give you another factor. So it can't be prime. So that one's done. Okay, it's a little trick what you have to do. You have to factorize this expression, make whatever this number is, n, and get out another factor out from it when you factorize this. Okay, so yeah. So you could do a general kind of proof of that. I mean, shall I do it? I'm just in two minds. Because you could say, if that was any number, and you say that you could do n take away 1, call that any number b. So if the expression was something like this, let's say this expression was n squared minus bn plus a. So you could call this, factorize that and say that's going to be n minus b, and that's going to be plus a. And then you could say let n equal a, and then that will give you, this expression will then become a minus b plus a, and then you got, when you factorize that, you get the a out, and in here you will end up with a minus b plus a, which will give me a 2a minus b. So you got another factor as well as a and 1, right? So if it just had a and 1 factors, it'd be a prime. But this has got another factor, which is 2a minus b, as well as a and 1. Okay, I don't know if that made sense. Sorry, I hope I haven't confused you guys. But you could use that as a general kind of rule. That'll be true. Let's have a look at b. So it goes here. Prove that n squared minus 1 never prime when n is a whole number greater than 2. Well, first of all, that's the difference between two squares. So n squared minus 1 is going to give me n plus 1 and n minus 1. Now when n is greater than 2, then you're going to have more expressions. In this expression, you're going to have more factors. So there's going to be more factors than 1 in itself. Okay, so you're going to end up with, when n is greater than 0, you will end up with more factors than 2, therefore not prime. Okay, you're going to end up with more factors. So I don't know, if n squared was, if it was 3, then you'll end up with 3 take with 1 is 2, and 3 plus 1 is 4, so that one, it won't work.